point 2. So beginning of chapter 8. We're talking about reciprocals. What reciprocal is when I look at this, it has the x in the bottom of the function. X in the bottom of the function means that it is a reciprocal. So when I'm talking about my parent function is this right here, 1 over x. And then we have all these transformations, which we know, because we are smart individuals, already know what's going to happen. This a is going to either flip it, stretch it, compress it. When I have this h, that's with the x value, it moves left and right. That's always opposite. And when I have this k value, that moves up or down. It's just, again, depending on what the graph, what is the actual transformation doing to the actual graph. So I'm looking at this problem. We will always come back to this thinking process each and every time. So if you ever say, hey, I don't know what to do next, get out your notes, look at this thinking process. So my first thing is, what's the transformations? What is going on in the equation? When I'm doing this, x cannot equal h, because if x equals h, then there's a bigger scenario, because we cannot divide, because that's essentially what reciprocals are. We cannot divide by 0. Okay, so did the function move left or right? If it does, that's going to affect your vertical asymptote. Vertical, think of vertical when you jump up and down, affects the line that goes this way, vertical asymptote. Did I move up or down? That's going to affect your horizontal asymptote. Horizontal asymptote looks like this. Is the y-intercept. What is y when x equals 0? So if I plug 0 in for x here, what number do I get out? X-intercept, when I plug 0 in for y, you might have to use your calculator to check this. Now if we go back to the parent function, you can see that in my parent function, my vertical asymptote is at 0, because if you look right here, it does not pass that. So if I move left or right, it would move this vertical asymptote, meaning it's that dotted line. So when you draw out a picture, I should always see that vertical asymptote as a dotted line. That moves left or right. That's my h. My horizontal asymptote moves up or down. That's my k. So this is the transformation that moves the asymptotes. Let's try it. How about it? So again, looking at that thinking process, first I need to decide what's my transformation. When I look here, that's with my x value. That's always opposite, so this is going to move left 1. When I look here, that's not in my parent function, so this is going to move down 2. So when I actually write this out, my vertical asymptote, that's my x. This is my x, left and right. Vertical asymptote is x equals left 1 is -1. That's a -1. My horizontal asymptote moved down 2. That's all y equals. You must have the x equals and the y equals. If you don't, I'm not going to give you full credit. Wah, wah. Okay, before I get into my x-intercept and y-intercept, I'm going to plot my vertical asymptote. So here where x is equal to -1, right there, and it's going to be that dotted line all the way up and down. And then I have my horizontal asymptote. My horizontal asymptote, where y is -2, it's the same direction as the tick marks if you were to draw it without a graph, the tick marks. So then this is what I am dealing with. Now I have to find my y and x intercept. So if I find my y-intercept, that means x is 0. If I find my x-intercept, that means y is 0. Okay? So this one's going to be an easy one to solve. So I plug 0 in for x. So my y-intercept means I plug 0 in for x and I solve for y, because this is equal to y. Whoa, you can't see what I just wrote. Sorry. So y-intercept, plug 0 in for x. So I solve this either in my calculator or my brain. I'm going to use my brain. 0 plus 1 is 1. 1 divided by 1 is 1. 1 take away 2 is -1. So -1 is equal to y. I need to make sure to have that point on my graph. So 0, -1. So I have my y-intercept. X-intercept gets to be a little bit more tricky. So my x-intercept, same thing, I'm plugging 0 in for y. So now it's 0 is equal to my equation. Just like that. First thing I want to do is try to get my fraction by itself. So I'm going to add my 2 over. So 2 is equal to 1 over x plus 1. Because of this, you always want to get rid of this division. I have to think, what's the opposite of dividing? You got it. It's multiply. Notice how I put this whole thing in parentheses, because I'm multiplying this whole shebang by 2. Now, what's left over here, I just divided by this. This 1 is still left there. There's two ways you can do this. You could divide by 2 next, or you could distribute. I'm going to distribute. I like to leave my fractions at the end of the problem instead of in the middle. So I distribute both to the x and to the 1. So I have 2x plus 2, so I'm going to subtract 2 first. So 2x is equal to negative 1. Divide by 2, and I get x is equal to negative 1/2. So I need to see that written over here. So x-intercept, here's negative 1/2, 0. Now my other points, I can use a graphing calculator. So we push that y equal button. We get this, anything you have cleared out. Now you can either do the fraction key, or else when you do the fraction key, your answers will be in fraction mode. I like to have my answers in decimal, so I'm going to go 1 divide, and then in parentheses, everything on bottom, I'm going to put in parentheses, close that parentheses, minus 2. So now I'm going to go to my table. Now when you go to your table, you should see an error. You should see an error wherever the asymptote for your vertical asymptote is. So this is a great checking point. Now when you're graphing, we typically graph from negative 10 to 10, so there's not too many nice numbers. Here's a nice number. I'm going to plot this number right here, negative 2, 3, because negative 2, negative 3, sorry, negative 2, negative 3, 1, 2, 3. And the other nice number, any nice numbers that I have, we already have 0, negative 1. You could plot these other decimals if you want, but when you are graphing, these should not touch your asymptotes, and it should be a curve that ends up where the asymptotes create or cross each other. These should always be kitty corner. If for some reason these loop-de-loops that don't touch the asymptotes are not kitty corner of each other, you did something wrong and you need to check your work. So right now, I want you to pause the video and try to do the second one by yourself, going through the thinking process. So pause the video. First step, thinking process. What are the transformations here? Right 4, up 6. Second step and third step is what's your vertical asymptote then? So you got x equals 4, y equals 6. I'm going to plot those on my graph. If you've not plotted those on the graph, try to plot those on the graph. So my next step in my thinking process is what's my y-intercept? So again, y-intercept means if I plug 0 in for x, that's what you're solving. And by plugging that in, dun, you should have got 5.75. So we do the same thing now, and we try to find the x-intercept. So again, that x-intercept is when, again, right, 5.75 right here. X-intercept is when the y is 0. So if you're like, I can't remember which, if it's x-intercept, there should be a number here. X-intercept should have a number for the x and then 0 for the y. So again, what's that going to be equal to? You plug that 0 in for y. Subtract the 6 this time. Again, we need to get rid of this division. Again, notice the parentheses. Distribute your negative 6 in. Negative times a negative is a positive. Subtract my 24, so that's a negative 23. Divide by 96. Again, when I'm graphing, I like to have my answers as a decimal. So then plot those 2 points. Yes, try to plot those 2 decimal points on your graph. Plug into your graphing calculator. When I look at this, I have my 3, 5. That's a nice point that I'm going to graph. 4 is my asymptote, which is good. That's a good check. And 5, 7. So I plot my points, draw what I call my loop-de-loops. Do not cross the asymptote. Do not cross or touch that asymptote. And then bing, bada, boom. Answer. There you have it. Easy peasy and lemon squeezy. Have a grand, have a wonderful day.